Hello, so today in this module we're going to take and build a circuit that allows us to control a tricolor LED and with 3 potentiometers, and with it we can brighten and dim each individual color, and then of course make any one of an arrangement of colors with the tricolor. The new concept is going to be analog write. We've been using analog read for quite a while, and that's what we're going to use for these potentiometers here. But in this case we're going to analog write it. I will point out that analog write in Arduino is an 8-bit function, so it's going to be 256 values that we'll be able to send out. And we do have three potentiometers here, each being tuned in and sending out a 256 different values. So a quick bit with a calculator will give us the total potential here. So we're going to have 256, for example, of the red times 256 of the blue times 256 of the green means we should be able to get about 16.8 million different colors by doing it this way. So that being said, let me demonstrate it real quickly here. I'm going to put this diffuser on here, this 3D printed diffuser, so it doesn't saturate my camera as much. I'm going to dim and brighten the blue, and I'm not going to go very far because it tends to saturate the camera. And here we have the green, and here we have the red. So I can blend these colors to make those 16.8 million different colors by changing the intensity of each individual color correspondingly. All right. So I'm going to disassemble this, and then we're going to reassemble it. So let me pause it, and I'll see you in a second. Okay, so to build this circuit, you're going to need 3 potentiometers. You're going to need a tricolor LED. Okay, notice that mine is a common anode, which then perhaps is a little less common than a common cathode. So that longest wire is going to be hooked to positive, where some of you might be having common cathodes that are hooked to negative. So be wary of that. And I'm going to use 3 1K resistors, 1,000 ohm resistors, that I'm going to use to feed or sync, in this particular case, the tricolor LED. Notice the spacing on these potentiometers are every other hole. Okay, so what I'm going to do here first is I'm just going to lay these out so I can see where they are. Let's kind of space it like so. All right. And what I want to do is I want to have a power and ground going to either side of each potentiometers. In other words, on either pin on the outside, leaving a center one available. So I'm going to choose green from a ground, and I'm going to go ahead and, assuming I plug it in there, I'm just going to go this green to ground, and I'm going to go this green to ground, and I'm going to go this green to ground. And like I said, we're going to go ahead and have the other end of each potentiometer go to positive. So I'm going to go here to positive. And I'm running out of good colored wires, but I'll go from here to the positive bus. I'm going to move this one over so I have room to actually plug my power into this board. And that goes to positive. Okay, so now what I can do is let's go ahead and hook up some power and ground to the board itself. So to do that, I'm going to take this black wire, I'm going to hook it into the common ground bus, and I'm going to plug this into one of the ground pins over here on the Arduino. And I'm going to take this red wire, and I'm going to plug it into the positive bus, and I'm going to plug that into 5 volts. So now each one of these potentiometers should have power and ground going into them. So the next thing we need to do is gather the data, which is going to be off the center pin of the potentiometer. So I'm going to have 3 longer wires. I'm going to set it into the centers. And in this particular case, because we might be doing something with random, and I'm going to use A0 for that. I'm actually going to use A5 for this one over here on the farthest left. I'm going to use A4 for this one here that is in the middle. And I'm going to use A3 for this one. Okay. So if I go ahead and plug these potentiometers in, we can actually do a quick test to see whether or not they work. Let me pause it and get a piece of software out. Okay, so I've got a blank sketch. What I actually want to do is I want to go to File, Examples, Basics, Analog Read Serial. Because what we want to do is to see if we've got this hooked up correctly. Okay. I don't like the fact that it goes at 1 millisecond. I'm going to set that at 100 milliseconds. And like I said, what we ended up doing, let me go ahead and get rid of this one here, is we have it hooked up on pins A5, A4, and A3. So what I really want to do is I want to test each one of these. So I'm going to start with A5, and I'm simply going to load this software up just as it is with these two minor changes, changing it to A5 and increasing the delay. And I'll open up the serial port. And what we want to do is we want to see whether or not we're getting readings. And of course it's at 1023, which means that right now all the electrons are going to the pin. But if I turn the potentiometer, it does go all the way down to 50. Actually, I'm surprised at that. I would have thought it would have went to 0, but we're down to 50. Okay, let's check A4. I'll do that one real quick and load it up. And now we're going to check this middle one here. Move this over here a little ways. And 1023 down to 50. Okay, and we'll do a last check here. Let's do A3. And then we'll know that all three of these are properly wired. Awesome. Okay, we are properly wired in all of these. So, let me go ahead and pause this and we'll get the next thing. Okay, so I've actually got a little 3D printed clip that I'm using to hold these wires out of the way so you can see this part of the board. But now what I want to do is I want to take my tricolor LED, and again, please note the longest wire is the most important one on either a common anode or a common cathode. Okay, so in this case mine's a common anode, and this is going to be mean that I have to supply my positive voltage to this longest pin. So I'm going to take careful attention. I'm going to choose a pin or a column that's easy to identify. So I'm going to choose column 30 right here. And I'm going to put my longest wire in column 30. And I'm going to spread the other ones out on either side of it. So I'm going to take a total of 4 columns. It's a little bit hard to get in there. There we go. Okay. So I've got one wire in each column, and I've got the longest wire in column 30. So I'm now going to take a wire. I seem to be running out of red wires. Here's one. And I'm going to run that anode over to the positive bus. And now I'm going to use 3 1K resistors, and I'm going to use those to span across the IC gap. So I'm going to put one right there. And I'm going to put one right here. And I'm going to put one right here. Now we can do a quick test to make sure that it's properly wired. If I take this wire right here and put it into ground, and I don't have to stick it in the hole, I could just touch the resistor on this end. Okay, so clearly I've got a good circuit there, and I've got a good circuit there, and I've got a good circuit there. Okay, by allowing this end of the resistor, okay, this end over here, to ground, that completes the circuit, and I have each of the 3 colors lighting up. So now what I want to do is I want to hook these 3 resistors into the pulse width modulation ports, PWM ports, and they're designated by that squiggly line next to the PWM on this board. And that means that the only pins that I can effectively use for this purpose on this particular board is 11, 10, 9, 6, 5, and 3. Okay, you notice each one of those has that squiggly line next to it. I'm going to keep it kind of clean and neat, and I'm going to choose pins 9, 10, and 11. Okay? So let's go ahead and choose 9. I'm going to put 3 wires in 9, 10, and 11. So, and I'm going to plug them in sequence. Okay? So I'm going to put 9 here as my first one. I'm going to hook it to that resistor. And I'm going to take 10 and hook it to that resistor. And 11 and hook it to this resistor. Okay? So now I have 9, 10, and 11 carefully plugged into the same, I'll move this wire back a bit so you can see it, into the same columns as these resistors. Okay, are now going to these PWM pins 9, 10, and 11. Alright, let me pause it and set up a little piece of test code so we can see how it's working. Okay, for the sake of time, we're going to keep this code pretty streamlined and just kind of move it along real quick. So the first thing we have to do is we have to set the direction of the pins that are going to be used for the LED. We need to set them as an output. I think we're going to play with just this potentiometer first and just the red portion. We'll make that work and we'll copy and paste it. So that's going to be, in my case, pin 9, and we need to make sure that's set to output. All right. So now we have set that one to output. Let's go down here and make a function. Let's call it we'll call it dim LED. All right. And what I want to do is I want to create a variable that I can collect this data. All right. So I'm going to create an integer variable, and I'm going to make it called red LED, and we're going to make it equal to, we're going to analog read, in this case, pin 5. So we want to analog read. We want to measure A5. Okay, whoops, gotta make that corrected. Awesome. So now we want to output this data here. But remember, this thing goes from 0 to 1023, or from 50 to 1023. This can only handle up to 255, or 256 discrete points. So therefore, what we really need to do is we need to compress this to fit into this. All right. Now we could do something sort of simple. We could divide it by 4, but the better way to do it, which would get us close, but we could, the better way to do it would be to map it, okay? Because we really want to go from 50 to 1023, which is a little bit harder to do with simple math. So let's go ahead and write to this LED, okay? So we are going to analog write, and then what are we going to analog write to? We're going to analog write to this pin, all right, which is pin 9. And then what are we going to analog write? Well, we're going to analog write the mapped value of the red LED. Okay. And we're going to go from 50 to 1023. And we want to go 0 to 255. Let me make this a little bigger so you can see it. Like so. And I think that that in and of itself should work. We need another, close that bracket off. And let's see what happens. We'll save it. And we're going to call this my LED test. And we'll save it. And let's load it up in a moment, as soon as it gets done. I'm going to pause it. I'm running out of time. Of course, I have to call the function, which I had neglected to do before pausing it. But it actually is running now. Okay, so if I turn this potentiometer, I can brighten and dim the LED. And really, all we have is basically 2 lines of code. We gather the data, we map it, and then we analog write to the output. So in the next little video, I'm going to expand on this, and I will see you really soon.